Hi, hello, this is Paneer. In this video, we are going to see about pharmaceutical inorganic chemistry unit 10, that is limit test. Under this unit, we are going to cover the following contents that are definition of limit test for chloride, sulphate, iron, lead, heavy metals, finally limit test for arsenic. What is limit test? Limit test is a semi-quantitative test designed to identify and control small amounts of impurity which is likely to present in pharmaceuticals. What is the importance of the limit test? To check whether the possible impurities are present within the pharmacopoeial limit or not. Second important content is to ensure safety of the drug. So this is the main motto of performing limit test. What are all the limit tests? Already we see 6 in number. The first one is limit test for chloride. The limit test of chloride is based on the reaction between soluble chlorides with silver nitrate in presence of dilute nitric acid to form silver chloride precipitate, which appears as a opalescence. The opalescence produced in the test solution is compared with the standard opalescence. How we can conclude the result in the sense, if the opalescence lesser than the standard indicates the limit test is passes. If the opalescence more than the standard, it indicates limit test is fails. Here we need to know the importance of why we are adding dilute nitric acid. We are adding the dilute nitric acid to make a solution acetate and the silver chloride, that end product, to produce opalescence. This is the reaction. Chlorine reacts with silver nitrate in presence of dilute nitric acid. You will get AgCl plus NaNO3. Here that AgCl produces the opalescence. Next limit test is sulphate. The limit test of sulphate is based on the reaction of soluble sulphates with barium chloride in presence of dilute hydrochloric acid to form barium sulphate, which appears as a turbidity. The turbidity produced in the test solution is compared with the standard turbidity. The purpose of adding dilute hydrochloric acid is to make the solution acetate and barium sulphate solution to produce turbidity. The reaction is sulphate reacts with barium chloride in presence of dilute hydrochloric acid, forms barium sulphate as a turbidity. If it is a chloride limit test, opalescence. If it is a sulphate limit test, the end is turbidity product, their opalescence product. How we can compare? Already I said in the limit test of chloride, we have to compare with the standard one based on the opalescence chloride, based on the turbidity, here the sulphate, more than or less than. If it is more than, test fails. If it is less than the standard, test passes. What next? Limit test of iron. Limit test of iron is based on the reaction of iron in ammonical solution with thioglycolic acid in presence of citric acid to form iron thioglycolate ester, which is pale pink to deep reddish purple in color. The end color. The color produced in the test solution is compared with the color produced in standard solution. Already we know it. Here ferric ammonium sulphate is used as a standard. What is the reaction? Iron react with thioglycolic acid in ammonical solution in presence of citric acid. You will get the iron thioglycolate complex. It looks like pale pink to deep reddish purple in color. Here why we are adding this iron-free citric acid in the sense, iron-free citric acid added to form ion thioglycolate complex. Then the citric acid reacts with ammonia, because we are taking ammonical solution, right? Ammonia to form ammonium citrate, which is act as a buffer and stabilize the iron thioglycolate complex. Then what is the use of ammonia? Ammonia is added to make alkaline medium because iron thioglycolate is colorless in neutral and acidic medium. There is a purpose of why we are adding ammonia solution and citric acid. You can see the reaction. This is the reaction. That iron reacts with thioglycolic acid. You can see the complex now. Thioglycolate, iron thioglycolate. This is the color, the end color it looks like. Next, limit test of heavy metals. Limit test of heavy metals is based on the reaction of metallic impurities with hydrogen sulfide in acidic medium to form brownish color solution. Metal that responds to the test are lead, mercury, bismuth, arsenic, antimony, tin, cadmium, silver, copper, and molybdenum. You can take any of the metal. This metal is going to react with the hydrogen sulfide and it's going to produce metal sulfide in the acidic medium. Here we used to add ammonia and acetic acid to keep the pH 3 to 4. Why? Because we have to conduct this reaction heavy metal versus hydrogen sulfide in acidic medium. So we have to use ammonia and acetic acid to maintain the acidic medium. This is what the limit test for heavy metals. The reaction between heavy metal and hydrogen sulfide, it gives you metal sulfide in acid medium. What next? Limit test for lead. Limit test of lead is based on the reaction of lead and diphenyl thiocarbazole, that means dithiazone, in alkaline solution to form lead dithiazone complex, which is red in color, green in color in chloroform. Lead thiazone complex is violet in color. Because of this combination of green and violet, end result you will get red color. This is what happened in limit test for lead. Okay. What happened here? Reaction of lead and dithiazone. See here. Lead and dithiazone. Why you are saying thiazone means S is indicate thi, there are two azo group. So dithiazone, you can see that diphenyl, you can see this diphenyl group is there. It reacts with lead and it creates complex lead dithiazone, which looks like red in color. This is what the limit test for lead. Next is limit test for arsenic. Limit test for arsenic used to called what modified Ketzite test, because we are using here Ketzite apparatus, so that called the modified Ketzite test. In this test, the arsenic impurity present in the sample is first converted into arsenious acid by suitable reducing agent like potassium iodide, zinc, hydrochloric acid, and stannous chloride. Then the arsenious acid is reduced to arsenic gas by the action of nascent hydrogen, which is produced by the reaction between the zinc and hydrochloric acid. The liberated arsenic gas reacts with mercury chloride vapor and it forms yellow stain. This is what happened in the limit test for arsenic. You see the reaction. So very simple. Arsenic acid is converted to arsenious acid by using reducing agent like zinc, hydrochloric acid, stannous chloride, and potassium iodide. The next step, this arsenious acid react with this nascent hydrogen. It produces arsenic gas. How nascent hydrogen is created? This is created because of the reaction between the zinc and hydrochloric acid. Finally, this arsenic gas reacts with this mercury chloride. You will get the yellow color. Here we use the pipeline lead acetate rule. For what we use the lead acetate rule to prevent the black stain in the pipeline. This is what that limit test for arsenic. So We have covered what is the definition of limit test. Further, all 6 limit tests for chloride, sulphate, lead, heavy metals, arsenic, all we have covered. I hope this video is useful to know about why we are conducting limit test and what are all the limit tests and what is the basic principle behind this limit test. Thanks for your valuable time. If you like this video, kindly share the video those who in need by subscribing my channel. You will get the video once after posting video immediately in your view. Once again, thanks for your valuable time.